Hello, welcome back to another video. In the previous 3 videos, we talked about classes. We created 3 different classes: the student class, the credit card class, and the vending machine class. And we went over topics like the class constructor, data members, methods, and even the string operator, which allows us to print the object or just convert it to a string format. So in this video, we're going to be talking more on operator overloading. So in Python, operator overloading is done using Dunder methods. So Dunder stands for double underscore. So if you remember the string operator, we had double underscore, string, double underscore. So what are operators? We've seen some of them before, like plus, minus, multiplication, division. We can also have less than, equal, greater than. So these are all operators. So let's use an example with a list. If we had a list with 1, 2, 3 and a second list with 10, 20, if we wanted to add these two lists together, we would just do list 3 is list plus list 2. And if we print list 3, we get 1, 2, 3, 10, 20. Now, maybe we don't want to create a new object because when you call the plus operator or when you add, it creates a new list object. Maybe we just want to modify a list. So the way we would do so is list plus equal list 2. So let's save and print it, and we get 1, 2, 3, 10, 20. Another way to do it is calling a method extend. So let's comment this out and run it, and we get the same thing. So you can see extend and the plus equal, they do the same thing. But what is the difference? The first one is an operator, and then the second one is just a method. You can tell because it's list dot method name with parentheses, and you pass in your parameter. Okay. So an operator is a shorthand way to add functionality to your classes. So in this video, we're going to be creating a complex number class because we want to practice overloading the arithmetic operators such as addition, subtraction, and multiplication. If you've forgotten what a complex number is, it's basically you have a real number, so 7, plus an imaginary number. So it's 7 plus 3i, so this is a complex number. So in Python, we don't have a data type that would represent a complex number, at least not in the standard Python library. Maybe they might have one if you download a module or something. But complex numbers can be useful if you're doing some advanced math stuff, but we're not going to be working with that. We're just going to represent complex numbers using a class. So the format is a plus bi, right? So a is your real number and b is the coefficient in front of the imaginary number, which is square root of -1, right? So I is square root of -1, and if you take I squared, you get -1, right? So we're going to create a class to represent the complex number. And let's start with our constructor. So underscore init, and it will take an a and b, and let's assume that it will always be integer numbers. We'll just do self.a equals a and self.b equals b. So we only need the real number and the coefficient in front of the imaginary number. We don't really need something representing I, because again, I is always the constant square root of -1. So after that, we have some test code here. So we created our first complex number with 5 and 2. So we should get 5 plus 2i. And the other one is 3 and 3. So 3 plus 3i. Let's run it. And you can see because we did not overload the string operator, we cannot have a string representation, so it defaults to the data type, complex, and the memory location. So why don't we do that? So underscore string self, and we will return string of self.a plus addition, and plus string of self.b, and let's not forget the I. So let's run it this time, and we get our representation: 5 plus 2i, 3 plus 3i. Now let's talk about adding. So when you add two complex numbers, it's pretty simple. If you add these two numbers, so let me uncomment this out, you get 8 plus 5i, right? Because you just add the real numbers and the imaginary numbers. So 5 plus 3, that's 8. 2i plus 3i, that's 5i. So with add, you create a new complex object. Similar to when you add two list objects, you create a third list object. So if you were to use a method, it would just be add, and you would have self and other. So self refers to the first complex number and other refers to the second complex number. So you would just do new A is going to be self.A plus other.A, and new B is going to be self.B plus other.B, and then you return a new complex object with new A and new B. So if we did that, we can see that we did not overload the plus operator. So we should do .add cplx2, run it, and we get 8 plus 5i. But because we're working with numbers here, wouldn't it be easier if we could just call plus instead of calling a method .add, right? It would be easier to do this. So instead of having the add method, we just do underscore underscore add underscore underscore. So now when we run it, we can see we get 8 plus 5i. So that's how you would overload the add operator. So this is the string operator, this is the add operator. Okay, and maybe we don't want to use temporary variables. We can clean up our code just by directly putting the sum here. All right, and let's get rid of that. So let's run it again, and we get 8 plus 5i. Okay, cool. Now let's talk about subtraction. And subtraction is pretty simple. Instead of addition, you just change these signs to subtraction. So let's copy and paste this and change add to sub. So plus to minus, plus to minus. And it says here we should get 2 minus 1i. So if we run our code, we get 2 plus minus 1i. And so it has something to do with the way we format the string. So maybe you want to add an if condition. If self.b, if this is negative, then change the sign to negative. I'm just going to leave it for now. You could work on that if you want. And if we flip it actually and make it complex 2 minus complex 1, we should expect the negation of this. So it should be negative 2 plus 1i. So let's run it. So you get negative 2 plus 1i. Okay, so that's subtraction. All right, so let's work on multiplication. So how does multiplication work? You just use the FOIL method. So if you paid attention in class when you were taking algebra, you have a plus bi times c plus di. You just distribute. So a times c plus a times di. So the first two right here. And then you have bi times c plus bi times di. So you get this format. And remember, we said I was square root of negative 1. So if you square that, you get negative 1. So we can put this into two groups. This would actually be AC plus ADI plus BCI minus BD. So now we have two groups. We have two sets of real numbers and two sets of complex numbers. So multiplication, self other. So this should be di squared, which is equal to AC minus BD. So this is our real number, and AD plus BC. So this is our imaginary number. And let me actually add this in the comments. A represents our real number, and B is our imaginary number. So when we multiply, let's do return complex. So our real number set is self.a times other.a. So self.a times other.a minus self.b times other.b. Okay, so this is the real number for both self and other, and then this is the imaginary number for both. When you take two imaginary numbers and multiply them, you get the negation, right? Because square root of I squared becomes negative 1. And then for our imaginary number, you take the inner portion, so it's this part. So it's self.a times other.b plus self.b times other.a. Okay, so now if we uncomment this out, let's comment this out, we get 9 plus 21i, which is what we get here. Also, just to double check that we did not modify the original two complex numbers, if we print them once more, we should get 5 plus 2i and 3 plus 3i. All right, so that's operator overloading using Dunder methods in Python. So just to reiterate, we have add, we have sub, we have mul, string. If you want to do plus equal, it would be iadd. So self and other, and then it would be self.a plus equal other.a, self.b plus equal other.b, and then we just return self. So here, if we did cplx1 plus equal cplx2 and print it, the very last line, we get 8 plus 5i. Okay, so that's using iadd. And yeah, hope you enjoyed the video, and see you in the next one. Bye-bye.